Welcome to the deep dive. Today we're diving into something really critical in AI right now.
Mm-hmm.
It's about these huge language models, LLMs, large language models, and how we get them to, well, forget things.
Right. Things they shouldn't have learned.
Exactly. Private data, copyrighted stuff, the kind of information that sneaks into those massive training data sets. It causes huge problems.
Absolutely.
And you might have heard about the New York Times lawsuit against OpenAI. That really puts a spotlight on it.
It really does. And the core challenge, I think, is that these models, they're just designed to learn so much. But what do you do when some of that learning is, well, wrong or unauthorized?
Yeah, and just retraining them from scratch.
Forget about it. The scale, the cost.
Yeah.
It's just not practical most of the time.
Which brings us to this idea of unlearning, like teaching the AI to forget specific things.
Precisely. It's about finding a way to induce maybe selective amnesia.
Selective amnesia for AI, I like that. Now, I know there are ways people try to do this already. Things like gradient-ascent.ga.
Yes, GA, and also negative preference optimization, or NPO. Those are some of the established methods.
And here's the catch, right? These methods often mess things up. They can actually harm the model's ability to, speak properly, generate sensible text.
That's exactly the problem, and it's a serious one. The researchers we're looking at today actually make a comparison.
Yeah.
They liken it to the linguistic difficulties sometimes seen in Alzheimer's patients.
Wow, really? That's quite a comparison.
It is, but it highlights the issue. You know how Alzheimer's can affect vocabulary, sentence structure? These reverse optimization techniques, GA and NPO, can sometimes have a similar degrading effect on LLMs. You end up with outputs that are maybe repetitive or incoherent,
Yeah.
just not fluent.
Okay, so why does that happen? Is there a reason these methods cause that kind of damage?
They've pinpointed something they call the probability seesaw effect.
Probability seesaw. Okay, break that down for us. Analogy time.
Analogy time it is. So imagine the model learns that after peanut butter and Gull, the word jelly is super likely.
Makes sense.
Now, GA and NPO try to push down the probability of jelly, but they're a bit, let's say, heavy-handed. In pushing down jelly, they might also accidentally push down the chances of other perfectly good words, like crackers or honey.
Ah, I see. So it's not targeted enough. It just kind of suppresses everything in the vicinity.
Exactly. It's indiscriminate. This reverse optimization just lowers the likelihood of lots of words, even correct ones. And that leads to two main problems.
Which are?
First, vocabulary collapse. The model basically has fewer words it feels confident using, so its language becomes less varied, less fluent.
Okay.
And second, contextual incoherence. Even if the words themselves are okay, the way they're put together doesn't really fit the context anymore. The meaning gets lost.
Right. So the existing ways of unlearning can make the model forget, but also make it kind of broken, linguistically speaking.
In many cases, yes. That's the risk.
Which is why we're diving into this new approach today called ReLearn. And the big difference you're saying is that it doesn't use that reverse optimization.
Correct. ReLearn flips the script. It uses positive optimization for unlearning. Instead of trying to force forgetting, it actively teaches the model something new.
Okay, positive optimization. How does that work in practice? What are the main techniques?
At its heart, ReLearn relies on two core strategies. Data augmentation, basically creating new training data, and then fine-tuning, which is further training the model on specific data sets.
Learning to forget, not forcing it. And what are the big goals here? What guides ReLearn?
Two main principles, really. First, obviously, it has to successfully make the model forget the sensitive or unwanted information that's non-negotiable.
Makes sense.
But, crucially, the second principle is that the model must still be able to generate relevant and coherent responses. It needs to remain useful and fluent. It's all about finding that balance.
Okay, balance is key. Let's dig into that first strategy. Data augmentation. How does ReLearn create this new data?
It starts with something called question augmentation. Let's say the original question that gets the bad answer is, what is your email address? ReLearn automatically generates different ways to ask essentially the same thing. They have 4 types. Symbol variance, can you tell me your email? Context variance, what's your email for business stuff? Noise variance, maybe with a typo, what is your email? And logical variance, how can I contact you electronically?
Huh, interesting. So it creates a whole family of related questions.
Exactly. This generates a diverse set of prompts, which they call DICQ.
So you've got all these new questions related to the sensitive topic. What next?
Next comes answer augmentation. For every single one of those augmented questions in DICQ, ReLearn generates a new answer. And these new answers, called AAG, are designed to be deliberately vague.
Vague. How so?
Well, they have to meet three really important criteria. 1, unlearned, meaning absolutely no original sensitive info. 2, relevant, it still needs to generally address the question's topic. 3, no risk.
Yeah.
It can't accidentally introduce new, private, or sensitive details.
Gotcha. So instead of giving the email, the model learns to say something like,
Exactly. Something like, I can't share personal contact details, or you can reach out through the official website. It replaces the specific sensitive answer with a safe, general one.
okay, that makes a lot of sense. So you're actively teaching it a new safe response pattern and this bunch of new question-answer pairs. That's this kiosk set.
That's the one. Just cue off.
But how do you make sure those new vague answers are actually safe? Couldn't they accidentally leak something else?
Good question. That's where content verification comes in. They actually use other LLMs, guided by a technique called chain of thought analysis, basically asking the AI to explain its reasoning step by step.
Ah, using AI to check AI.
Pretty much.
Wow.
It assesses if the newly generated vague answer might still pose some kind of risk based on predefined safety rules if it flags a potential issue.
Back to the drawing board.
Exactly. It goes back to the answer augmentation step to try again and generate a safer alternative. It's like a built-in safety net.
Smart. Okay. Built-in safety check. The outline also mentions data diversification. Why do they need to diversify this data further?
All right, there are two parts to this. First is sentence completion, creating a data set called DSCF. The idea here is that if you only train on question-answer pairs, the model might get too locked into that specific format.
Overfitting to Q&A.
Precisely. So they take those vague answers they generated, like, say, information about individuals is kept confidential, and break them into sentence completion tasks. So the model might see information about individuals is kept and learn to complete it with confidential.
Okay, so it learns the new safe knowledge in a different format, making the learning more general.
That's the goal, make it more robust. The second part of diversification is the generic data set, DIG.
Why bring in generic stuff?
This is super important to prevent what's called catastrophic forgetting.
Sounds bad.
It is. It means if you focus too much on making the model forget specific things, it might accidentally start forgetting all its useful general knowledge too, like how to answer basic facts or perform simple reasoning.
Oh, right. You don't want to lobotomize the model just to remove one piece of bad info?
Exactly. So they mix in this generic data set, DAG, just random general knowledge questions from standard data sets like WikiQA or chatbot instruction to keep the model's overall knowledge base healthy. For some of the tests they ran on benchmarks like TOEFL and NoUndo, they actually mixed this generic data one-to-one with the augmented forget data.
Okay, so the final forget data set, Dev, is a mix of those augmented Q&As and the sentence completion bits, sometimes blended with general knowledge. Got it. Now, how does the actual learning part work? How does ReLearn use this data?
Right. This is the unlearning via learning, the ReLearn objective part. The core idea is fine-tuning. ReLearn retrains the model, but very specifically using 3 data sets together.
Near miss. The augmented forget set.
Dev, yes, that's 1.
The stuff it should keep remembering.
The retain set, Dr. Dex, that's 2. It's the original non-sensitive data.
And the general knowledge stuff.
And the generic data set, DIR, that's 3. So it's learning from Dev, Dr. Danjag all at once.
Okay, and how does it balance learning from these different sets? There must be some math involved, some loss functions.
Exactly. They use different loss functions to guide the process. For the forget set and the generic set combined, they use a standard method called cross-entropy loss. Let's call it LGDF. Think of this as pushing the model to produce the new vague answers for the forget questions, and also to keep getting the general knowledge questions right.
Okay, learn the new vague stuff, keep the general knowledge. What about the retain set, Doctor?
Also, cross-entropy loss, called LGDR. This just encourages the model to keep predicting the correct answers for the information it's supposed to retain. Keep the good stuff good.
Makes sense. But wait, the outline mentioned a third loss? Something about KL divergence?
Ah, yes. The Kullback-Leibler divergence loss, LKLR. This one's a bit more subtle. It measures how different the internal predictions of the ReLearn model are compared to the original model, but only when looking at the retained set. Dr.
Okay, what does that achieve?
Think of it like a gentle nudge. It encourages the ReLearn model to process the retained information in a similar way to how the original model did, without strictly forcing it to match exactly. It helps preserve the the nuances, the subtle understanding the original model had about that retained knowledge.
So it's not just remembering the facts, but remembering how it understood those facts in a way.
That's a good way to put it. It aims to prevent the unlearning process from distorting the model's understanding of the stuff it's meant to keep.
So the overall training is guided by adding these three losses together: LGDF, LGDR, and LKLR.
Precisely. LReLearn, LGDF plus LGDR plus LKLR. That's the combined objective guiding the fine-tuning.
Okay, this sounds quite sophisticated.
Mhm.
But the million-dollar question: how do you know if it actually worked? How do you measure success?
Yeah, that's crucial. And the researchers point out that the standard metrics people used to use, like RGL or perplexity, PPL, are often, well, not great for this.
Why not? What's wrong with them?
Well, Bugel mainly looks at word overlap. A model could just outcome a very long, repetitive, but vaguely related answer and get a decent ORG score, even if it's nonsense.
Right.
And perplexity, which measures how surprised the model is by the next word. It can be low even for gibberish if the model consistently predicts the same nonsensical word over and over. Remember that example you mentioned?
Yeah, the model just saying at, and getting a good PPL score, not very helpful.
Not at all. So ReLearn needed a better evaluation framework. They proposed 3 new key metrics.
Okay, let's break them down. First up, knowledge forgetting ratio, KFR. What's that measuring?
KFR, knowledge forgetting ratio. This one, as the name suggests, measures how well the model actually forgets the target knowledge. It combines 2 underlying scores: entity coverage score, ECS, and entailment score, ES.
Entity coverage score. Does that mean checking if specific names or details are still there?
Exactly. NCS looks at the model's output and checks if the critical entities, the key bits of info from the original answer it was supposed to forget, are present. And it uses smart techniques like sentence transformers to check for semantic similarity, not just exact matches. So if the answer was 555121 and the model says a phone number starting with 555, ECS might still pick that up.
Okay, so ECS checks if the sensitive pieces are still appearing. What about the entailment score, ES?
ES uses natural language inference, or NLI. Think of NLI as a model that determines the relationship between 2 sentences. Do they agree, disagree, or are they neutral?
Right.
For forgetting, they feed the NLI model the ReLearn model's output as the premise and the original sensitive answer as the hypothesis. If the NLI model says the output contradicts the original sensitive answer, that's a strong sign of successful forgetting.
Okay, so KFR combines these. Forgetting is successful if either the key entities are mostly gone low ECS or if the new answer actually contradicts the old sensitive one, according to the NLI model.
Precisely. They use a threshold, C1, for the ECS score. If ECS is below this threshold, like 0.3 in their tests, or if the NLI detects a contradiction, then KFR counts it as forgotten. The low ECS provides a backstop even without a direct contradiction. If the core info is just gone, it's considered forgotten.
Makes sense. Okay, that's forgetting.
Yeah.
What about the flip side, making sure it remembers the stuff it's supposed to keep? That's the knowledge retention ratio, KRR.
Exactly. KRR, knowledge retention ratio. It also uses ECS and ES, but the logic is reversed.
How so?
For retention to be successful, you need both things to be true. The entity coverage score, ECS, for the retained information needs to be high above a threshold. C2, also 0.3 in their tests. And the entailment score, ES, should show no contradiction between the model's output and the original retained information.
So for KRR, keep the key entities present and don't contradict the facts you're supposed to remember.
You got it. High ECS and no contradiction equals successful retention.
Okay, forget ratio, retention ratio. What about the language quality? Did it break the model's fluency, like GA and NPO sometimes do? That's the third metric, linguistic score, LS.
Yes, the linguistic score, LS. And this was really interesting because they drew inspiration from cognitive linguistics research on Alzheimer's again.
Yeah.
They look at how language changes in those conditions, things like reduced vocabulary diversity.
So LS tries to capture that linguistic health. How?
It combines 3 things. First, perplexity, PPL, as a sort of baseline fluency check. Second, Brunet's index, BI, which measures vocabulary diversity. Interestingly, a lower BI score means more diversity.
Okay, lower BI is better. And the third?
Honor statistic, HS. This measures lexical richness, basically. Does the model use a good mix of common and less common words? Higher HS means richer vocabulary.
PPL, BI, HS. How do they combine into one score, LS?
They use the harmonic mean. First, they do some math to get them on a similar scale log transform, negate PPL and BI, since lower is better for those, then use a sigmoid function to squash everything between 0 and 1. The harmonic mean is good because it penalizes really low scores on any single component. You need to do reasonably well on all 3. perplexity, diversity, richness, to get a high overall LS.
Clever. So a high LS means the language is generally fluent, diverse, and rich. And did they check if this LS metric actually matches, like human judgment?
They did. They used GPT-4o, a very capable model, to independently rate the fluency and relevance of the outputs from the different unlearning methods on a 1 to 5 scale. And they found that their LS scores generally lined up well with these GPT-4o ratings, which gives confidence that LS is capturing something meaningful about language quality.
Excellent. So we have ReLearn, and we have this comprehensive way to evaluate it, KFR, KRR, LS, plus external validation. What did the experiments actually show? Did ReLearn live up to the hype?
Well, the results looked pretty promising. They tested it on standard unlearning benchmarks, Noando and TOFU, using models like Llama 2.7 BChat and Gemma 2.2 Beat, fine-tuned with LoRA, that's low-rank adaptation, and efficient tuning method.
Yeah.
And ReLearn consistently got a good knowledge forgetting ratio, KFR. So it was effective at forgetting the target stuff. But the really key finding was its knowledge retention ratio, KRR. It was significantly higher than the baseline methods.
So it didn't suffer from that catastrophic forgetting as much. I remembered the good stuff better.
Exactly. Methods like NPO-GDR, which combines NPO with retained set training, might get high KFR but often tank the KRR. ReLearn seemed to find a much better balance.
What about the language quality, the LS score?
That's where the difference was really stark. GA and NPO, as expected, caused a big drop in the linguistic score compared to the original model. You could see it in the GPT-4 ratings, too much lower fluency and relevance. ReLearn, however,
Yeah.
its LS score stayed much closer to the original model's level.
So it forgot effectively, retained well, and didn't break the language generation.
That's what the results suggest. The fluency and relevance scores for ReLearn were comparable to the original vanilla model. Looking at the example outputs in the appendix, Table 9, really drives this home. The JANPO outputs can be quite repetitive or nonsensical, while ReLearns are generally coherent. They also did human evaluations, Table 3, which confirmed ReLearn was good at forgetting while maintaining relevance, unlike others. Plus, it performed well on general tasks like MMLU and GSM-8K, showing it kept its general smarts.
Okay, that sounds impressive. What about robustness? Do they test how well it holds up under pressure?
They did. 2 main tests. First, parameter precision. They checked what happens if you reduce the numerical precision of the model's weights, like going from float 16 to bfloat 16. GA and NPO took a big hit in their forgetting ability. KFR dropped significantly. This suggests they might rely on very specific fine-tuned weight values. ReLearn, though, barely changed its KFR, only shifted slightly. It seems less brittle, less dependent on that exact numerical precision.
That's good for real-world deployment. What was the second robustness test?
Jailbreak attacks. They use a method called AIM adversarial instruct metaprompting to try and trick the unlearned models into revealing the information they were supposed to forget.
Trying to bypass the unlearning. How did ReLearn do?
This was really interesting. GA and NPO actually performed worse under the AIM attack. Their KFR dropped, meaning the attack was somewhat successful in getting them to reveal forgotten info. But ReLearn, its KFR actually improved under the attack.
Improved? How?
It suggests that the ReLearn process doesn't just remove the information, but it might actually strengthen the model's defenses against prompts specifically designed to elicit that information. It becomes more robust against revealing it. Table 10 has examples of these attack responses.
Wow. Okay, so it forgets, retains, stays fluent, is robust to precision changes, and even resists jailbreak attacks better. That's quite a list. Did they look inside the model to see why? The mechanistic analysis?
Yes, they tried to understand the how and why behind these results by looking at the model's internals. They examined knowledge distribution, knowledge memory, and knowledge circuits.
Okay, knowledge distribution first. What did they find there?
They looked at the probabilities the model assigns to words after a prompt related to forgotten info. Remember the probability seesaw?
Yeah.
They saw that GA and NPO really mess up the distribution. They push down the target word, but the probability either shifts to other random words, creating kind of uniform, confused state, or it might even shift to other high probability words that could still be problematic. It hinders coherent generation.
And ReLearn.
ReLearn guides the model more gently towards a new, coherent probability distribution centered on the vague, safe answers. It doesn't cause that same widespread disruption or cognitive conflict. Figures 5 and 9 show this visually.
Okay, less disruption. What about knowledge memory? How information flows through the layers?
They use an example, Carlos Rivera's mailing address. In the original model, layers activate concepts like address, location, but also specifics like Colum for Colombia. ReLearn, after unlearning, still activates related concepts like located, address, Carlos, maintaining some semantic understanding.
But not the sensitive bit.
Right. NPO, in contrast, might briefly activate address, but then degrade into just repeating generic words like at. And they looked at something called forward KL divergence across layers, which measures how information changes layer by layer. For JAMPO, this metric showed big disruptions, suggesting impaired information processing, which they again linked conceptually to memory loss. Figure 6 illustrates this layer activation.
So the way ReLearn works seems to preserve the related concepts better while removing the target one.
It appears so. Finally, they looked at knowledge circuits using a tool called LLMTT. Think of this as mapping the active connections in the model's brain when answering.
Okay.
At a low threshold, all models look similar. But ReLearn specifically seemed to weaken connections related to the sensitive entities themselves. When they raised the threshold to see only the strongest connections, the circuits in the original model and ReLearn became sparser. But GA and MPO actually strengthened circuits related to specific question patterns, like how does
Yeah,
it mix
that's
some of that?
interesting.
It suggests JNPO might be overfitting to forget specific phrases or question types, whereas ReLearn achieves a more general unlearning by targeting the underlying entity association, making it less sensitive to how the question is asked. Figure 11 shows these circuit diagrams.
Fascinating. Okay, so wrapping this deep dive up, what's the big picture, the main takeaway from ReLearn?
I think the key message is that ReLearn really represents a significant step forward. By using this positive optimization approach, teaching rather than just erasing it, manages to strike a much better balance. It forgets effectively, it retains crucial knowledge, and critically, it does this without sacrificing the model's linguistic abilities, its fluency and coherence. That's huge for making these models safer and more trustworthy.
It definitely sounds like a promising direction, but no research is perfect. Did the paper mention any limitations or areas needing more work?
Yes, they were quite upfront about that. One point is the computational overhead generating all that augmented data for ReLearn takes time and resources, which could affect how easily it scales to even larger models or datasets.
Right, the data augmentation part. Anything else?
They also noted that their new evaluation metrics, KFR, KRR, LS, while better than the old ones, might still have their own sensitivities or might not capture every single nuance of unlearning perfectly. More research is needed there. And fundamentally, they mentioned needing a deeper theoretical understanding of exactly how ReLearn restructures knowledge inside the model. The mechanistic analysis gives clues, but the full picture isn't clear yet.
Always more to learn about learning and unlearning. Lots to think about there. Thanks so much for walking us through this. It's been incredibly insightful.
My pleasure. It's definitely an exciting area to watch.
Before we wrap up, one final thought for our listeners. The paper briefly touches on practical unlearning objectives, especially around copyright. It suggests that for copyright, simply deleting verbatim text might not be enough. The goal might need to shift towards preventing unfair competition or unauthorized derivative works. It makes you wonder, doesn't it? How will technologies like ReLearn, combined perhaps with things like AI watermarking, change the landscape of copyright and intellectual property as AI continues to evolve? Something to chew on.